So let me introduce our next speaker, Ericka Smith. Her talk is called Addressing Gaps in Data Accessibility with Shiny Dashboards. Ericka Smith recently graduated with a master's in statistics from Oregon State. She has a strong passion for data accessibility. So with her background in natural resources, she has firsthand experience with everything that happens to data before it gets to R and after it leaves. This expertise gives her unique insight into the pitfalls and traps we can fall into as our users working with data that is not our own, as well as knowledge about how to avoid them. So welcome, Ericka, and I will get out of your way.
Thank you. Hi. So good morning, everybody. I, as you can probably tell, am coming to you from a car. My internet decided to not work today. So I apologize for the background. Today, I'm going to tell you about how Shiny dashboards are a great tool for creating truly accessible data. We'll specifically talk about this kind of in the context of some work I did at OSU. Myself and 3 other students, Emily Palmer, Kat Polham, and Jessica Robinson, whose info you can find in the version of my slides that are available for download, created a Shiny app to demystify complex climate models. We worked under the advisement of 3 faculty members, Lisa Gagno, James Molyneux, and Charlotte Wickham. And I'm really excited to tell you all how it turned out. So let's get started. First, I want to talk about what data accessibility is and why it's important. It sounds like it should be simple. It's just access to data, right? But in a world where data is currency and using the right data with the right spin can overthrow or create democracies, cause us to buy things we may not actually want, and silo our opinions such that it sometimes feels like we barely know our own families, it becomes about much more than that. It's about transparency and power. Data is an asset. And we know this. In Canada, there's the Open Data Canada initiative. It's been a priority since as early as 2010. In the US, there's data.gov. And it's actually codified in a variety of laws. M-13-13 is a memorandum from President Obama's time in office, and it states, making information resources accessible, discoverable, and usable by the public can help fuel entrepreneurship, innovation, and scientific discovery, all of which improve Americans' lives and contribute significantly to job creation. This value was again held up during President Trump's time in office. In 2018, Congress passed H.R. 4174. This is called the Foundations for Evidence-Based Policymaking Act of 2018. It says, and I quote, "This bill requires agency data to be accessible and requires agencies to plan to develop statistical evidence to support policymaking." And it's not just about that it's an asset. It's also about open science. As our users, we're working in a space that's built on science. And science requires reproducibility and integrity, which are really difficult to verify without access to the data used in the analyses. We saw this at the outbreak of the pandemic, where papers published in the New England Journal of Medicine and The Lancet had to be retracted when the company declined to make the underlying data for both of them available to independent audit. We also saw years of spider research retracted due to allegations of fraudulent data, where the irregularities, they were only able to be found when a publishing journal began requiring all data to be made available. These sorts of events breed mistrust in science, and making data accessible is one of our best defenses to that. So I've told you that it's important. I made it clear it's required by the US and Canadian governments. You're probably wondering what the issue is and why I'm talking to you today. I think we're missing the mark. Just because you can find the link to the data itself online, that doesn't mean that it's truly accessible. And I'm going to briefly take you through a case study to explain why. Yes, the climate data that I mentioned at the beginning of this talk, and the Climates team. This team was originally created to compete in the ASA section on Statistics in the Environment's 2020 Data Challenge, where we were just kind of given a pile of data and the open-ended challenge of doing something creative and informative with it. As this was a team effort that occurred primarily in a post-COVID world, I've included photos of the team cats rather than photos of the team itself. In the top left, we actually have a stock photo of a cat because not everyone had one. Then there's, a couple cats laying down, cuddling. Most notably, there's one cat lying on a person's back while they clean a fish tank, and another cat lying next to a plastic skeleton. So I thought this was a very important addition to the talk, just to kind of give you an idea of the team itself. But back to the data and the project. The data itself was over 230 gigabytes. We immediately found ourselves pretty lost. Which brings me to our barriers in this work. We had really obscure file and data types. For example, a lot of the data was in netcdf files, which was unfamiliar even to the faculty that we were working with. As it turns out, this is an input-output format for many GIS applications and for general scientific data exchange. It's typically used in science and also really often used in that open data that we're talking about on data.gov. We additionally had, as I briefly mentioned, really unwieldy size of data. Even just split up, one of the data sets was 78 gigs. I couldn't open it on my computer to look at. And so for that, we were lucky. We were working through university, so we were able to set up a server with our IT department. For the first hurdle, we were able to kind of research, learn different ways. There's actually some great R packages that we were able to use once we learned about the file types themselves. And so these two first ones greatly increased the barrier to entry, but we ourselves had the resources and the time to figure it out. But we also had to get any sort of understanding of the data itself. And this is a group of statisticians, not a group of climate scientists. So this was a pretty big task for us. For example, one of the data sets, it's called the CESM Lens data set, which is the National Center for Atmospheric Research Community Earth System Model Large Ensemble Community Project funded by the National Science Foundation. This is described, and I quote again, as a publicly available set of climate model simulations intended for advanced understanding of internal climate variability and climate change. And that publicly available part is where we take issue a little bit, because we realized in trying to do this project that this data was not truly publicly available. And most data isn't. There's so many barriers to entry when it comes to taking advantage of these great resources, because the sheer amount of background knowledge and technological access that you have to get started is insane. So it's safe to say it's a problem. And you're probably wondering what we should do about it. I don't have the answer to that, not entirely, but we did take a crack at it and we came up with a scalable approach that I think works pretty well. The primary solution, why you're all here today, was that we created a Shiny dashboard as a tool. That was huge in addressing these issues. The user isn't interacting with the code or the data themselves, so they can't get stuck with large data sets. They can't get stuck with the obscure file types. The size we addressed in a multifaceted manner, which kind of in summary was being very intentional about the things that are calculated and when we calculate them. Pre-processing data in certain ways allowed us to decrease the size significantly, and again, using the Shiny app allowed us to test that we had sufficiently taken care of the issue. Making models approachable to a general audience was a more significant undertaking. We solved this issue via the design of the dashboard, which caused us to kind of give a really careful consideration to navigation and how we led the users to higher levels of complexity. Again, through Shiny interface that was really testable, we were able to do this in a way that just attaching metadata or writing a report doesn't allow you to do. So ultimately, these data went from an initial state of requiring significant knowledge and resource investments to even look at to being approachable to anyone with a link to the website. Here's the dashboard itself. In the top left, there's an Overview tab and an Explore the Data tab. The link here takes you to the overview first, if we were to just open it. And that explains the project and gives information about the data. The picture that I have for you here is of the Explore the Data tab. And then below that, we've got 4 more separate tabs where you can explore different information and different concepts from the models. We've got model variability, decadal cumulative precipitation, yearly total cumulative and by-month variability, and seasonal precipitation deviation. Then on the left, we have a map. You can select a space in the contiguous US, and the app will create plots based on each of these 4 concepts and that space. You can even pick an additional spot on the map to compare. This interactive nature is a vital aspect of what makes this such a great tool for creating accessibility, which is just one of the reasons why Shiny is so great. I encourage you to check it out for yourself. Again, the slides are online, so don't worry about trying to copy this down right this second. Now to the real question that you all should have at this point is, how can I do that too? You'll find a multitude of advice online, but these are just my tips. The first one is that you really can do this. No Shiny app has to be as complex as the one I've shown you today, and it also doesn't need to be created with such a hefty data set. There's a ton of resources online, and it feels like a high initial investment to learn, but the Shiny apps are so versatile that you can continuously apply your new skills to different data. So start with teaching us about Iris, teach us about cars, teach us about your favorite sports team. Then maybe hit data.gov and see if there's something you can help others to understand. Take data from your work and share it with your boss, share it with your coworkers. Just make sure that before you get started, you choose an audience, because you want to be able to tailor your app to their needs. And you want to ideally try and get a member of that audience to be your guinea pig and give you feedback on accessibility, on if they're following what you're talking about and what you're doing. And also keep in mind that a simple takeaway, a few concepts, can be a lot more powerful than a deep dive. Of course, that depends on your audience, but for example, with our Shiny app, the data itself was actually temperature data and precipitation data. But we didn't think that it was going to be as valuable just to give people the idea of the model if we tried to include both. So we really focused on precipitation. And finally, I'd just like to make some acknowledgments. Again, as I mentioned at the beginning, the Climates team, Emily Palmer, Kat Pullum, and Jess Robinson, and our faculty advisors, Lisa Gagno, James Molyneux, and Charlotte Wickham. I'd also like to thank the organizers of this conference, the CESM Large Ensemble Community Project for their data, the European Center for Medium Range Weather Forecasts for their data, and of course, CJ Keist, who set up our IT services and got us that server. And that is all. I'll answer any questions during the Q&A. Thank you.